Hello, and welcome to another episode of the EnVisioneering Exchange, the podcast where industry leaders discuss the most important topics in sustainability, climate change, buildings, and urban efficiency. I'm Vic Marinich from Danfoss, and I'm delighted to be the host of this podcast. You can subscribe to our show on Apple Podcasts, Spotify, SoundCloud, or wherever you get your podcasts. Today, we have Justin Proser, Senior Product Compliance Specialist at Danfoss, to talk to us about the evolving codes and standards for the HVAC industry and how these changes can be managed. Justin is a Senior Product Compliance Specialist at Danfoss and has a BS in Engineering from Penn State University. Justin, thanks for taking the time to be on our show.
Thank you, Vic. Really nice to be here.
So maybe can we start a little high level, and can you tell us some more about your background and how you got into the work of product compliance?
Yeah, I started off at a small engineering firm called TOLK in the Washington, D.C. area, and they were later bought by Dewberry, but they were designing commercial office spaces, the HVAC systems for them. And I went from there to AHRI, which is Air Conditioning, Heating, and Refrigeration Institute. And I was working on their certification programs, the chiller certification program and compressors and VAVs, and later just moved into a technical advisory position. And then 4 years ago, started at Danfoss and made the jump into industry.
Okay. So you were an insider for a while there. Very nice. Very nice. Yeah. So maybe before we get started, and first to the audience, we could maybe get a little bit wonky here as we dive into the discussion with lots of different names and numbers and acronyms thrown around there. So no need to worry. We'll put all of the necessary links in the show notes so everybody can refer back and as we start talking about things, make sure we have the information correctly. But as we jump in, maybe some of the basic foundational definitions, right? We're going to be talking about laws, standards, codes, and maybe everybody, at least I certainly did, thought, well, they're all just the same thing anyway, right? But they're not. Can you maybe tell us the differences?
So, for example, if you have a state like California, that's a very big state, and they need to ensure that the buildings in their state are safe for the people there. They need to create building codes that determine that safety. The legislators have no idea how to write those requirements. So in the US, there is an organization called IAPMO. And IAPMO writes the building standards for California, and I think one other state and another jurisdiction. Those building standards then reference codes like ASHRAE 15, which sets safety requirements for the systems within those buildings. The systems standard, ASHRAE 15, then references product codes or product standards, such as UL 60335 series. The 60335 series references component standards. Could be other 60335 series, or it could be individual component standards like UL 207, which applies to valves and heat exchangers. And the companies need to comply with those individual standards and codes wherever they are within the entire compliance chain.
Yeah, super interesting. It gave me that aha moment that, of course, legislators, you almost never see them run commercials for, hey, I know all about building construction or whatever, right? But yet they're the ones writing all those laws. So they have to rely on somebody to be smarter about how to build those buildings and how to build the equipment that goes in the buildings and the equipment that goes in the equipment in the buildings and so on. So to me, made it really crystal clear. The codes and the standards are there to help the legislators make sure that the laws they're passing around, let's say in this case, building safety, are tested, tried and true, are reasonable, and all that good kind of stuff. So, and I guess that means then we have to really have a good interaction between the public sector and industry, right? Because if we're just lobbing bombs over the wall to each other here and hoping that the other side is paying attention, then we probably don't get very good laws or standards or codes, right?
Yeah, and there's another piece of this that a lot of folks outside of the US don't understand. The manufacturers don't have to comply with these standards and codes in order to install their products within buildings. Ultimately, they need to convince the authority having jurisdiction, which is the building inspector, to approve their product to be installed in the building. The easiest way to do that is to comply with these standards and codes and have the third-party lab put their mark on the product. But that's not a requirement. The law doesn't say you have to do that. Ultimately, the law is going to rely on the building inspector to confirm compliance.
So we're seeing all kinds of changes going on right now. And, I've been around a while already, and it seems like now we've got a lot of different variables, let's say, flying around all at the same time here. I can look back and I remember the big R22 to 410A transition, right? But that was one old refrigerant going to one new refrigerant, right? I remember we had on the residential side the 10 SEER to the 13 SEER increases. But that was one product, one offering, one change. And now it seems like we're just getting all kinds of different things coming at us all at once, right? I mean, we're getting minimum efficiency requirements coming, whether it's at the component level or the unit level, or now even people thinking about the building level. We're getting refrigerant restrictions. So it's not just to go from refrigerant A to B, but depending on applications and markets and regions and all that stuff, could be lots of different refrigerants. We're seeing chemical restrictions around health and safety coming. And then we're seeing more, at least an attempt at global harmonization, so that obviously suppliers who are making products in one region can rather easily sell them in other regions, right? We want to make sure we have economies of scale and then that we keep the industry competitive and so on. Kind of the common theme, I think, is about the environment, keeping the global warming below 2.0 degrees C. And part of that, too, is electrification, right? So how can we get away from burning fossil fuels? But in such a chaotic, let's say, situation that we have right now, what do you see? What are the most relevant codes and standards right now that are working to address all these issues that legislation needs to work through?
Unfortunately, there isn't one or two
Exactly.
code or standard that is working to address all of these. There are many, and they are sometimes competing. For example, as you said, the minimum efficiency requirements generally in the U.S., we look at the IEEE or IECC standard, the residential model code. For the commercial minimum efficiency, we look at ASHRAE 90.1. And at least at the commercial side, and probably also at the residential side, folks are looking more at a system level than an individual component level, because there's only so much you can do with vapor compression cycle to get the most out of a product. How much better it would be to take that waste heat that you've generated and plug it into your hot water during the summer, or vice versa in the winter. And from an energy efficiency standpoint, that's what a lot of people are working on. How do we take heat out of data centers and put it into the adjoining office building or residential condos? As you said, how do we move to electrification and away from burning fossil fuels? But at the same time, as we're looking at using the vapor compression cycle more, we're also having restrictions on refrigerants, so that we need to change our products. And as we're changing our products with restrictions in the AIM Act and EPA SNAP regulations, or in individual state regulations in California, Washington State, and New York State, those refrigerants are different and usually more hazardous. They're more flammable, they're more toxic, even if they're better for the environment. This is in line with the chemical restrictions that are coming up. Anyone that's in the chemical restriction world is familiar with the PIP 3-to-1 restriction that came across very quickly from the EPA. And now we're talking about removing PFAS, which is in almost everything that we use. So in addition to that, all of our safety codes in the US are transitioning to these international codes, or the US version of these international codes. And that's the globalization of standards, which tends to be good in some ways and bad in other ways, because it means a lot of change for manufacturers to understand the complexity of it.
Yeah, and when we have those code changes, again, right, we're in the U.S. a very unitary product if we think on the air conditioning side, right, rooftops and so it's lots of air-to-air units, whereas Europe is a lot of water-based boilers and hot water for domestic comfort heating and stuff. So even if we're using the same standards, probably the way we're going to have to apply them, the regulations around them and all that stuff is going to have to change, just because we're inherently different markets, right, here to Europe to Asia and so on.
Yeah, not only different markets, but different construction requirements, different building inspection requirements, and a different legal system that tends to have greater liability across the board for businesses and people here in the US than we have in Europe.
Yeah, for sure. Yeah. Insert lawyer joke here, right? But I won't. So, but on the refrigerant restrictions, so you kind of touched on the A2L side of things where we have A1 is a non-flammable refrigerant and A2L is mildly flammable as defined by ASHRAE, I guess it is. But, if you think back, the refrigerants that we were using before, 410A or going back to R22 or whatever, I mean, we were using them because they were good refrigerants, right? I mean, so they were efficient and effective, and unfortunately they had all these significant downsides of ozone depletion and global warming. But we're moving to refrigerants that in theory could be less efficient and effective, right? So it's not even just that we're going to these flammable ones, but I imagine units may be getting bigger, more complicated. If we're going to electrification, right, then we're talking maybe variable speed. So there's a lot more to it than just stop buying 410A today and start buying 454B tomorrow, even with the safety taken into account. There's whole system designs that are going to have to be redone and then redone to these new standards, right? So it's not 410A and, an ASHRAE standard, it's 454B and a UL standard. So it's really a ton that, the component suppliers, the equipment suppliers, and then the building owners all are going to have to go through here in these coming years, right?
Yes. But the conversation is worth it, right? So 410A has global warming potential of over 2,000. An A2L R32, a very popular one, has global warming potential of 675. And then if you go even further, R290, which is an A3 refrigerant, has a global warming potential of 3. So we're sort of moving in these orders of magnitude toward these substances that are much better for the environment. But as we move toward that level, they become more flammable and more dangerous to use.
Mm-hmm. Right. So there's no free lunch, right? Everything's
Yes.
a trade-off, right?
Yes.
Yeah. And how about the timing for all this stuff? So are building owners or homeowners, for that matter, going to start seeing these changes tomorrow, 2 years, 10 years? What kind of timing are we looking at? Because I guess there is a process, as you said, right? We need the codes and standards written, and then they have to become incorporated in the law, right? So I imagine there's some hurdles that have to be crossed, right?
Yeah, and they've already started. January 2024 is the start of the phase down of refrigerants as restricted by the AIM Act. And that phase down will continue to different products across the spectrum of the industry, from HVAC to commercial refrigeration to different products within those two sectors.
With all these moving parts, I think most of them we as an industry have managed through before, right? Efficiency changes aren't really anything new. We try to make the components more and more efficient, the compressors, the expansion valves, the heat exchangers, ultimately get more efficient components, and we keep driving down that path. And even refrigerant changes aren't that new. We talked about going from R22 to 410A. But the move to A2Ls and mildly flammable is a big deal, right? I think it took us as an industry a lot longer to get comfortable at that point. And now we start talking about maybe A3s, which are highly flammable, right? We're talking then butane, propane, and some other gases potentially. So you mentioned a bit on the wine move, right? We have environmental concerns that we need to make sure are addressed. But how do we see industry addressing the risks that are coming with those changes?
So we're still right in the heart of the change with A2Ls. Even though the transition and restrictions have started already, the safety standards are being updated weekly to address new understanding of those requirements. And the main push is to be able to effectively implement the use of these flammable refrigerants within the different products and different building types. And yeah, there's a lot to do there. And really what it comes down to is the amount of refrigerant that you can have in a given space is restricted by the amount that could leak out and potentially cause a fire. So we have to be able to address that safety risk so that we don't have any issues in the building because nobody ever wants to install their system in the building and then there's an issue. So everyone's doing the absolute best they can to make sure that never happens.
And that's today with A2Ls. So I guess, are we going to have to kind of have a version 2.0 of that once A3s come around?
Yeah, certainly.
So we're working on the here and now, but we kind of already see on the horizon that we're going to have to do this all over again somewhere down the path. Yeah.
Yeah. And it starts with research. We need to understand in a lab if there's a leak and there's a fire, a spark, what's going to happen to that building. And then it goes, that research creates data. That data goes into the safety codes and standards. And then we start building products that meet those requirements.
We talk about the laws, code standards. When we talk HVACR industry, I mean, that's just a massive breadth of products, right? I mean, we could be talking about a vending machine or a under-counter refrigerator that's got maybe grams of charge, all the way up to these massive, big, centrifugal air conditioning chillers, at a couple thousand tons each. So I have to imagine the expectations on what you need to do to, let's say, put a vending machine in your office building versus to put in a couple thousand tons of air conditioning are quite different. Like what you've got to go through to, let's say, mitigate the different levels of risk. How is that looked at today?
When we're working on these safety standards, we consider a single point failure, and we address a single point failure. And from a refrigerant leak mitigation standpoint, there are levels of risk mitigation depending on how much refrigerant is in the system. For instance, you could have a very small amount of refrigerant in the system, and if it leaks out, who cares? If you have a butane lighter and it leaks out, nobody cares. You can put that anywhere, and it doesn't matter. It's not going to cause a risk to anybody. But if you have some more refrigerant, then yeah, it needs to have enough space to leak out into and not be below a certain concentration. Generally, that's 25% of the lower flammability limit of the system. So, and as you can see, there's a huge safety factor ×4 built into that. So we've already taken a very conservative approach. Following that, you can get greater concentrations, and beyond that, you need leak mitigation systems, detect a leak, close valves so you don't leak too much refrigerant, turn on fans so you don't have a very high concentration in a very small area, turn off the compressor or any other large system that may cause a spark. And beyond that, you got to be in a special room. It's called an ASHRAE 15 machinery room.
And I assume that room, if you've got equipment like, big centrifugal chiller in a room, then it's going to have its own dedicated alarm and management system, right? Where you're detecting the leaks and getting rid of the refrigerant, that kind of stuff. Yeah.
And that's where we've been really solid for a long time. The ASHRAE 15 machinery room concept has been around for a while, and they were thinking about things as toxic as ammonia or even the higher flammable refrigerants. So there's leak detection, there's ventilation, there's charge limits, there's personnel limits into that space, and it's really locked down. Where it becomes difficult is where, now we have a refrigerant that's in a hotel room, and anyone can go in a hotel room. And so you need to make sure that if there's kids sleeping on the floor, they're safe if there's a leak. That's the idea.
Right. The mechanical room is run by professionals who are trained to make sure everything is safe and so on. But right, I guess the air conditioner in the home, the vending machine in the hotel lobby, all those other things now, if they're suddenly, I don't want to say more dangerous, but have the flammable fluid in them, then we need to put things in place to make sure that where today that hotel or that office building or whatever really isn't managing the products. They just need to have the capabilities with, like you said, leak detection and those kinds of things, right? Mm-hmm. Okay. So it sounds easy, right? You have a system, and if it's above X charge, then you have to do this. If it's below X charge, you don't, and so on. And it sounds, okay, it's complicated, but it sounds simple. But I mean, if you start thinking in real life, right, you have a supermarket, and the supermarket's probably got a bunch of rooftops for the air conditioning. It's got a bunch of display cases and frozen food section, probably has some vending machines in the front, an ice machine in the back, and who knows. So how's that entire ecosystem, if you will, looked at when it comes to the codes and standards? You have to look at it as the whole thing, or is it just a sum of all the different points, or how's that addressed in the building?
So right now, the codes and the standards are addressing the individual products and keeping the customers or the people working around those systems safe based on an individual product performance in case of a refrigerant leak. But we need more work actually to update our safety codes to combine these different systems. And there's a lot of work being done as recent as this past week to take that type of thing into account. For example, in a grocery store, if you have a walk-in cooler and freezer and you have a rooftop unit, as you said, both serving the space at the same time, both with their different refrigerant systems, each of those systems does have a risk mitigation and procedures and requirements in place to address them, but the code hasn't been written to address those risks together. So if the HVAC system, for example, has a leak, right now the code would imply that the entire store would shut down because of that. And that may not be desirable for the building owner or the people trying to buy frozen food.
Yeah, or the people trying to maintain hundreds of gallons of ice cream or whatever else it is in there. Yeah. So it is right. Individually, it sounds pretty smart, but that kind of scenario that could be pretty painful, I have to imagine, for a supermarket. But just because you have a rooftop leak doesn't mean you also have a cold room leak, a display case leak, a vending machine, right, or whatever it is. I mean, the chance of those 10 different pieces of equipment all to leak at the same time is probably pretty low.
Exactly.
Right.
And there are solutions out there to manage the leak, the potential risk of fire and life safety. We just need to build that into the code in more of a performance, not prescriptive requirement sense, so that we can allow the engineers to be brilliant and solve this problem.
Right. Yeah, and I think that's probably a good kind of summary at the end, right? There's a lot of moving parts, a lot of things to worry about and to consider. But at the end of the day, this move from A1 to A2L and then down the road to the A3s, I'm sure for people like you, we've been talking about this for, 5, 6, 8, whatever it's been years, right? Getting everything up and ready for 2024, 2025. So I think the safety concerns are being addressed, right? The technology is being addressed. We've kind of got everything coming together here to make sure that when this is done, it's done right, it's done well, it's done safely and efficiently. Some challenges at the building level, clearly, but I think the big takeaway here from the codes and standards is that there's been a lot of people putting a lot of effort. I know AHRI did a lot of testing on the A2L refrigerants and what happens with different leaks in different places under different conditions and all that stuff. And I think that's all on their website where you can read all those final reports on all the testing and what happens if you put in A2L into an A1 system. I mean, so much work has been done to make sure that things stay safe. And it's good that we have people like you to help get those codes written and done so that the legislation can hopefully take it and apply it intelligently. So maybe to that end, I don't know, is there anything else you want to cover or you want to mention before we sign off here today?
I think what's not always crystal clear to folks is how fast this stuff is moving. So as you said, there's been many items completed over the years. The research has been done, but as early as mid last year, we were finalizing requirements for A2L refrigerant sensors. So that gave manufacturers almost no time to implement these things into their systems. The complexity is increasing, and the speed at which we're adapting to it, and that we need to adapt to it, is also increasing.
Right. And then I think it's back to that whole public-private sector interaction, right? I mean, we have to make sure we're working together and trusting each other. Yeah. Otherwise, laws are written that maybe can't be lived up to, or standards are coming out that won't make the laws. So that's super critical, right? Yeah. Awesome. Well, great. Thanks, Justin. I appreciate the time. And that's it for this episode of EnVisioneering Exchange. I'd like to thank my guest, Justin Proser from Danfoss, for joining us.
Thanks a lot, Vic. Really glad to be here.
Don't forget to subscribe to EnVisioneering Exchange on Apple Podcasts, Spotify, SoundCloud, or wherever you listen to podcasts. Lastly, if you enjoyed this episode, don't forget to rate, review, and share it with your network. Thanks for listening, and talk to you next time.
This podcast is for information purposes only. The views, information, or opinions expressed during the EnVisioneering Exchange podcast series are solely those of the individuals involved and not necessarily represent those of Danfoss LLC and its employees. Danfoss LLC is not responsible and does not verify for accuracy any of the information contained in the podcast series available for listening on this site. This podcast series does not constitute professional advice or services. This podcast, including Danfoss LLC and the producers, disclaim responsibility from any possible adverse effects of information contained herein. Opinions of guests are their own, and Danfoss LLC in this podcast does not endorse or accept responsibility of statements made by guests. This podcast does not make any representations or warranties about the guest qualifications or credibility. Individuals on this podcast may have a direct or indirect financial interest in products or services referred to herein. This podcast is available for private, non-commercial use only. You may not edit, modify, or redistribute this podcast. The developers of the EnVisioneering Exchange podcast site assume no liability for any activities in connection with this podcast or for use of this podcast in connection with any other website, computer, or playing device.